So panometrics has been around since the 60s. We started as a gas and moisture analysis company with aluminum oxide sensors, but we very quickly started to leverage the ultrasound technology for measuring flow. We've been doing ultrasonic flow measurement since the mid-1970s, and we are the leader in that technology. The next one. The great thing about ultrasonic flow measurement is that it really suits all industries. Obviously, oil and gas, petrochemical, refining. It's a great area to be in. But the technology works with any moving fluid. So water treatment, power jet, food and beverage, steel process. And we have almost unlimited applications across the industry. When we get to our gas and moisture on the analysis side, similar thing. Every industry, there's not one manufacturing site in the world that can't use moisture measurement. But what we're going to talk about today is flow. And we offer two technologies of flow measurement, our main one being ultrasonic measurement, transit time based, and both inline and clamp-on versions of those meters. We also have another technology called vortex, where we actually put a impediment inside of a flow line, and we measure the eddy currents that come off of that as the flow goes past. We can just go through the next one pretty quick here. So, when you're wanting to control your system, the first step is to measure and have confidence in your measurement. And with ultrasonic, whether it be gas, steam, biogas, natural gas, we're able to measure it all. Liquids are very easy to measure, but gas gets a little bit tricky because you have a lot more fluid dynamics issues that come up in those situations. Some of the common challenges that we have, throughout measurement is you have, a low or changing pressure in the line. You have on flares, we need to be able to measure from 0.1 feet per second up to 400 feet per second. So the wide range. Also, if it's just straight natural gas, fairly easy to measure. But when you have a variable composition in the line, it becomes very difficult to measure, and ultrasonics can handle that. Go through the next. All right. So there's a few main components when it comes to an ultrasonic meter. So first off, of course, we have the electronics. This is the electronics head up top here, and we have the transducers. And really, when it comes down to it, the transducers are the key to all measurement. It is a sensor. There are piezoelectric transducers, and they send a signal, one going on an angle upstream and one going an angle downstream. And what the ultrasonic meter technically is it's a time measurement. We measure the difference in time between going upstream versus going downstream, and that gives us the velocity through the line. Take the velocity through the line, multiplied by the cross-sectional area of the pipe, we get volumetric flow. That's how we do our measurement. So an analogy that we have listed here is that's rowing in a river. I have to use swimming as if you're swimming across the river on an angle, it's going to take you a little longer to go upstream than it is for you to swim downstream with the current or against it. So that's what we do. I think this slide may be duplicated. Go to the next one. Yeah, just go down again. So there's two main types of ultrasonic flow meters. The most basic one that is very common is called clamp-on. It's on the right here, where we take the transducers and we attach them to the pipe. Sometimes they're in this position where we actually bounce off the far side of the pipe and back. In a V format, we do a W format in the 4-pass. Anything that we need to do to get the pack length to the proper length. It's great for retrofitting. However, if you want more accurate, inline or wetted system has transducers that are actually they're actually in contact with the fluid. You're able to get much higher accuracy through this way and much more stable readings. It's also not contingent on the material of your pipe. So you normally get to a 0.5% accuracy. It's just right out of the box. So the main advantages of ultrasonic meters, there's no pressure drop in the line. It's a full bore meter, meaning you lose no energy as it travels through the pipe. That's a great thing. It also can do bi-directional measurement. If you have reverse flow, it will actually still work, which is rare when it comes to flow measurement. And then there's no drifting. Since we, based on the speed of sound, which is a standard, it's a standard unit, we don't have to do calibration. When you put it in, there's nothing for a meter to be out there for 15 years and still be accurate. It happens all through industry. But yeah, it's a little bit of a higher price in terms of the capex, but your operating expenses are rock bottom, almost zero when it comes to the flow measurement. So we wanted to talk about a couple little case studies. First off is biogas. So I'll just read out the background. A large European water company produces biogas from their wastewater facility. We need to accurately meter and build this gas, which is used for energy production by another party. So biogas is difficult because it's a changing mixture at all times. And the pressure is very low, but the pipes are pretty big, 12-inch line with under 1 psi. That's a very difficult measurement. So the solution is to go with the Panasonic or Panametrics ultrasonic flow meter. You don't have to worry about a pressure drop. When you're so low pressure, any pressure drop is significant. We can compensate for the changing stream composition. It's a difficult application that ultrasonics makes pretty easy. But no other flow technology can really do this and be both accurate and repeatable. So, any questions on that? Okay. Go on to the next one. So it's another biogas one. So background, the biogas measurement was required for reporting how much gas was used or being vented to the environmental authorities. Regulations are common in our industry, and biogas is no different from any other industry. So the challenge that was presented to us that mechanical meters with totalizers but no output are there. That's a very common measurement out there, whether it be a turbine meter or something magnetic. Every morning, an employee would have to go out, read the meter, record it, and calculate how much was produced in the last 24 hours. Not very user-friendly. Biogas is also notorious for being very damp. It's got a lot of moisture in it, a lot of junk in there. And so that would come up to the mechanical meters. So the solution, obviously, is Panametrics ultrasonic flow meter. It handles the wet gas very well. We can handle about somewhere between 5 and 8% condensate in our line, which is great for this application. Our PanaFlow DXG is the one that does this very well. And there's no pressure drop, so you don't have to worry about anything that's in the line, any of the dirt getting dumped up on any of the equipment in place. So this is a great long-term solution for them. Go through into the next one. So we have a number of different white papers, different documentation, different synopses of what we do. Let's reach out to your local Panametrics person. If you don't know who it is, just go to the website and hit the contact for more information, and we'll be in touch.